Sai Ram, welcome to Sri Sathya Sai Lok Seva Gurukulam, 6th standard. We are going through light, shadows and reflections. Children, in the last class, we have covered luminous objects, transparent, translucent and opaque objects and shadows. So, we are going to activity 5. You know what is that activity? Making a pinhole camera. You must have seen many cameras, but the origin of a camera started with pinhole camera. Okay, today we are seeing all the mobile cameras and big cameras and all. So the origin is from pinhole camera. Okay, so take two boxes of cardboard such that one can slide into another with no gap in between them. So two cardboard boxes, you know, you will get those boxes in any of the grocery shop or somewhere. So you have to select the boxes in such a way that big box, the small box slides into the big box. Okay, then cut open one side of each box. So take the both boxes, cut the other side and keep the other side intact. Then on the opposite face of the larger box, make a small hole in the middle. So the larger box. So the other side of the box, make a small pinhole like it's shown in the figure. Okay. So in the smaller box, cut out from the middle a square with a side of about 5 to 6 centimeters. So the uncut side, you cut a square of maybe side 5 to 6 centimeters. Okay, cover this open square in the box with tracing paper. That means translucent screen. Okay, like it's shown. See, a square and it was pasted with or stapled with a tracing paper. So we have learnt in the last lesson about a translucent object. So translucent object is tracing paper. Okay. Slide the smaller box inside the larger one with the hole in such a way that the side with the tracing paper inside is inside. So the tracing paper where we sticked, that side of the smaller box should slide towards the pinhole which we made on the larger side. Okay, your pinhole camera is ready for use now. Okay, so this is how it is. So the square what we cut and pasted the tracing paper is towards the pinhole side of the larger box. So it's like this. Now try to look at some distant objects like a tree or a building through the pinhole camera. So your camera is ready, pinhole camera is ready. Then you start looking at things around you. Make sure that the objects you wish to look at through your pinhole camera are in bright sunshine. Yes, this is a very important point. Unless there is light, like sunlight, you can't get the proper image on the tracing paper. So ensure that there is lots of sunshine. Move the smaller box forward or backward till you get a picture on the tracing paper pasted at the other end. So I told you. So you have to slide. See, the very purpose of selecting two boxes with larger size and a smaller size is to slide, to focus, because the light that comes from the pinhole, it has to come and fall on the tracing paper. Are these pinhole images different from their shadows? Yes, yes, they are not shadows, they are images. Look through your pinhole camera at the vehicles and people moving on the road in bright sunlight. Do the pictures seen in the camera show the colors of the objects on the other side? All these things you have to note it down, and these are going to make you aware how this pinhole camera works. Are the images erect or upside down? For example, you see this. So this is the pinhole camera, this is the pinhole, this is the tracing paper. It's just, so when they focused at a tree, it passes through like this and it reflects an upside down image. Okay, that's how it comes. Children, how to get a larger image from the pinhole camera? By moving the camera closer to the object. So naturally, if you want to capture a larger image, the camera should be closer to the object. Okay. Let us now image the sun with our pinhole camera. So let us image the sun with the pinhole camera. How do we do that? We need a slightly different setup for this. Okay, we need a different setup, not like the two boxes kind of a thing. We just need a large sheet of cardboard with a small pinhole in the middle, like this. Okay, this is a large white color sheet of cardboard. Hold the sheet up in the sun and let its shadow fall on a clear area. Just see, the shadow is falling on a clear area. Do you see a small circular image of the sun in the middle of the shadow of the cardboard sheet? Do you see that? See, you can see the sun, round circular thing. Okay. Look at these pinhole images of the sun when an eclipse is visible from your location. Okay, you know about eclipse, right? No? Okay, let me tell you. Eclipse is a phenomena in which when sun comes in between the moon and earth, it is called lunar eclipse. And when moon comes in between the sun and earth, it is called solar eclipse. Now we are talking about solar eclipse. Adjust your pinhole and screen to get a clearer image before the eclipse is to occur. So if you want to see an eclipse, so eclipse will start and end for a particular time. So before that, well in advance, we have to arrange our so-called pinhole camera setup. Okay. Look at the image as the eclipse begins. You'll notice a part of the image of the sun gradually becoming darker as the eclipse starts. See, like this. So slowly it closes the total sun. Never ever look directly at the sun. That could be extremely harmful for the eyes. Never ever look at the sun during the eclipse time because it gives lots of dangerous radiations which may harm your eyes. Okay, children? Something interesting about pinhole camera in nature. So, we see many things in nature. So, there are many interesting things in nature. So, let me show you something interesting. Sometimes when we pass under a tree covered with large number of leaves, we notice small patches of sunlight under it. So, just look at this picture in which there is a tree and above the tree is the sun and you can find patches of shadows with light patches. These circular images are in fact pinhole images of the sun. The gaps between the leaves act as the pinhole. So all these lights which you see, they are basically pinhole images because in between the leaves, when the sun rays strike in between the leaves, it forms pinhole images. These gaps are all kinds of irregular shapes, but we can see circular images of the sun. So these are all the pinhole images of the sun. Some thoughts on pinhole camera. Boyo has a thought. We saw upside down images of people on the road with our pinhole camera. What about the images of the sun? Did we notice them to be upside down or anything like that? See, when we see through pinhole camera, we know that the object which we see will be inverted when it becomes image. So in the same way, sun also gets inverted images, but because it is a circular symmetric thing, so we can't identify that. Okay, sun, a circular thing, whether it is upside down or Otherwise, it looks the same. Paheli has another thought. Surely, all these results that we are seeing, formation of shadows and pinhole images, are possible only if light moves in a straight path. Of course. So, light should pass through these pinholes in a straight path. So, then only we can be able to see these images, whether it is pinhole images or shadows. So, activity 6. So, let us use a piece of pipe or a long rubber tube. Light a candle and fix it on a table at one end of the room, just like this. See, there's a candle and the long pipe. Now, standing at the other end of the room, look at the candle through the pipe. Is the candle visible? So, if it is seen through the pipe, which is in straight line with the light, will you be able to see the light or not? Yes, you can see. Bend the pipe a little while you are looking at the candle. Is the candle visible now? See, if you do look like this, which is a bent one, which is not straight, can you see the light? No, you can't see. Turn the pipe a little to your right or left. Can you see the candle now? No, because light travels in a straight line. Children, another activity to show that light travels in a straight path. Take 3 cardboards and make circular holes in the center of each and every cardboard, which should be symmetrical. Okay, then place them in a straight line. All the holes should be in straight line, and just the other side light a lamp with a candle and see from the other side. Yes, because they are in the straight line, the holes are in the straight line, you will be able to see the light. So that means light travels in straight path. So what do you conclude from this experiment? This suggests that light travels along a straight line. That is why when opaque objects obstruct, a shadow is formed. For example, if you move either B or C little bit up so that the holes are not in the straight line, you can't see the light. In fact, if you move the C cardboard little bit up, you cannot see the light from here, but the shadow of the C will be visible on B. Do you know light travels much faster than sound? Yes, light travels at a speed of nearly 3 lakh kilometers per second. The distance around the earth is 40,000 kilometers. So, in 1 second, light could travel 7.5 times around the world. See, because light have got a speed of 3 lakh kilometers per second, when it travels, it can travel 7.5 times around the earth. Okay, sound only travels at about 330 meters per second through the air. So, light is nearly 1,000,000 times faster than sound. Naturally, 330 meters per second is the speed of the sound, and light is 3 lakh kilometers per second. See the difference, vast difference. Okay. Now, we are going to learn about one more phenomenon called bioluminescence. So, bioluminescence is the largest source of light in the oceans. So, we see the oceans, right? Sea. Under the sea, 90% of all creatures who live below about 1,500 feet are luminous. Means they emit some sort of light, because under the water, if you go deep, you can't have sunlight, but these so-called creatures will emit light for the visibility. Okay, human beings also glow. Yes, human beings, we also emit little bit light, but we as humans are bioluminescent, not unlike the jellyfish and fireflies. However, the light we emit is much too weak for our eyes to detect it. Yes, whatever light that we emit, okay, because it merges in the bigger light, so we can't able to see that light. So our beloved Swami's quotation on the light of the lamp of love. I have come to light the lamp of love in your hearts, to see that it shines day by day with added luster. So what is this added luster? Added luster means when the light of the lamp of love showers by Swami, our heart becomes brighter and brighter and becomes selfless and do lots of Seva. So children, so we are concluding the class now. So today we have learned about pinhole camera and also about light travels in straight line. Okay, so thank you. Tomorrow we are going to learn about reflections. Okay, in the next class.